question 15. We did this question together yesterday, right?
No. Yes. No, we did 14.
We did 14. So let's do 15. All right, 15. It says if IV is 36, VE is 20, EB is 15, find the width RI of the river. I think it's important, guys, that not only that, we see essentially that this is a question like, I guess I don't have a, it's a question just like this one up here. Okay? Would you agree that these two triangles here look like these two triangles?
Yes.
All right, kind of their orientation. So that's really what's happening is that the process that we went through up here is going to be the same process we go through down here. But I think it's important to understand that this does work. But I want you to understand how you would maybe in the real world kind of do this. Okay? And it doesn't have to be obviously the river. It could be anything that you want to measure the width of that maybe you don't want to cross, or maybe you can cross, but you just decide not to. We do this for maybe I want to find the width of a road, maybe the width of a sidewalk, something like that, width of a backyard, whatever I want to. Okay. Usually, probably something somewhat substantial in size. I don't want to find the width of your computer screen using this technique because you can't get a whole lot of dimensions to do that. Okay? But you could do this. All right. So here's the process that would happen. You would put yourself there at point I. All right. And you're going to try to find on the other side of the river a landmark like R that is going to create a perpendicular line between you and the shoreline that you're standing on. Does that make sense? So your line of sight is R to I. So you're standing at I, looking at R. So this line here is your line of sight. You're going to try to find a landmark R so that it is perpendicular. That line is perpendicular to the shoreline here. Okay? Should not be hard, right? You can do that. Okay? And if there's nothing over here, you can take a rock and throw it over there, and then just go stand in front of that rock so you're perpendicular to it, or perpendicular to the shoreline in front of that rock. Is that all right with everybody?
Yep.
Okay. Then you're going to walk an arbitrary distance from I to V. Does not matter the distance. Okay? But you want to make it something that's not ridiculous. You don't want to walk 2 miles, and you don't want to walk 7 inches. Okay? So here they walked 36 meters. Not a terribly large number, not a terribly small number. The smaller the numbers we use, because of our measurement here, the tools that we're using to measure, it's just going to be a lot more difficult. We use really small distances. So we get to V. Okay, we walk this arbitrary distance. Could be 36, could have done 80, could have done 15, whatever you want it to be. Place a marker there. You drop a stone, put a stick in the ground, whatever. Okay, just it's a visual marker, and you now have collected that data of how far that is. You then walk another arbitrary distance from V to E. Okay, does not matter that distance. Okay, going to this one they say it's what 20 meters. Okay, again it could be as big as you want, as small as you want. And then you're gonna record that data, and at that E you're gonna put another marker down, drop a stone, whatever. Okay, then you're gonna face the river again. All right, and when we face the river, that's going to try to get us kind of perpendicular to it, and we're going to start walking backwards. Okay, and we walk backwards until we can look at V, and right over the top of V, whatever that marker was, right over the top of it, we can line it up with R. Does that make sense? Okay, and that then becomes this point B that you put a marker at, and now you have determined or ultimately created by doing that process, you create those two similar triangles. Because the perpendicular situation where we try to align ourselves perpendicular gave the right angles, and then taking B and lining it with V and R is going to allow yourself to have a transversal that intersects that parallel line in that parallel line. And when you do that, it's going to force essentially that angle up top at R, this angle down here at B to be equal, right? So you have similar triangles. And that's the process that you would go through. So if I was on I-75, I want to figure out how far it is across 4 lanes of traffic, and it's a little scary to run across those with a tape measure, we could do this. Okay, it'd be really easy. So we're looking for RI, and we now know that these two triangles are similar. So I'm going to write that triangle RIV is similar to triangle. If I go R to I to V, okay, I need to start at what, B, and go to E, and then finish at V. And that's going to tell me that RI over BE is equal to IV over EV, which is equal to then RV over BV, right? And that's what we go. That's the process we go through all the time. We spent a lot of time yesterday on 14, kind of going through that several times. Now I fill in the things I know. Well, I knew IV was 36. I know that EV is 20. I know EB is 15. Neither of these values are able to be found because obviously they're, I could probably find B to V, but R to V is not going to be easily found because it's got to cross the river again. But those are the two ratios then that I need to set up my proportion. I get 20 RIs is equal to 15 times 36. So RI is equal to 15 times 36, all divided by 20. Whatever that equates to. You guys got an answer for that?
27.
27. Okay. 27. All right. So RI is 27 meters. Okay. My hopes are that we understand that. That's kind of like that question 10 above. And when you're doing that, obviously you probably didn't need that long discussion and description, but I think it's important to understand where we can apply this stuff. I find it, part of math in general is, can I do this stuff, or are these story problems feasible? Do they make sense, or are they just kind of making stuff up to show me that I can use it in a story? I always think that story problems sometimes are a little bit, I don't know, far-fetched. That kind of makes sense, the way they're written. But that's an example where you can see this thing happen. Number 16. What did you guys get for 16s?
I got 55.
Okay, it should be 5.5. 5.5 meters. Now, if you wrote 55 decimeters, you'd be right. Okay, so let's talk about the different places we could put decimal places and how that impacts our answers. When we look at this thing, first I want to talk about what this word, we're going to read this, to estimate the height of a pool, basketball player exactly 2 meters tall, stood at the ends of his shadow, and the shadow of the pole coincided. Okay, coincided means that they ended at the same time, right? Okay. He found that DE and DF measured 1.6 meters and 4.4 meters respectively. Does anybody know, and this is something that you could see in other classes, a lot of other classes, does anybody know what that word respectively means?
I did acknowledge. I like to.
Say it again? We need two something. You might be on track. We're on track there with that.
I like comparing.
Okay, it's comparing something. There is a comparison occurring here. What if I said, Tina and Linda are are Charlie and Mr. Fay's mothers, respectively? You know whose mom is Tina and whose mom is Linda?
Yeah.
Whose mom's Tina?
Yours.
No.
Charlie's.
Charlie's. Okay? Because I said Tina and Linda, right? I said them in that order. And then I said Charlie and Mr. Fay in that order, right?
So Tina would be Charlie.
So Tina goes to Charlie because they were first, right?
Yeah.
Okay? And then Linda goes to mine and Mr. Fay because they came second, right? Okay? So whenever you see that this goes to any course, science, math, English, okay? When you read things respectively, with the phrase respectively, there's a comparison of things, okay? And there's a characteristic being stated that you want to link then to certain objects. You link them in the order that they're stated, okay? So obviously in this question, if you didn't know what that meant, you can probably figure out that the short distance DE is 1.6, right? and because they give you the picture. And the long distance D to F is 4.4. That's something you could have done without that wording, that verbiage. And of course, exams, they might not give you the picture. Okay? Then you're kind of in a tough situation, right? Okay? So just keep those things in mind. I think a lot of times when we get to tests, quizzes for this class, other classes, we may struggle on those because our lack of vocabulary doesn't allow us to really understand what the question is asking and us to put values where they need to go and develop relationships that need to be developed. If I look at this, though, I'm going to look at that triangle there as G to F to D. Okay, so this is the height of the flag pole, or basketball pole, I guess. Right, is that what we're looking at here? Yeah, height of a pole. That's what we're looking for. Okay, it says then that basketball pole is casting a shadow essentially of 4.4 meters, right? Now, this triangle is the height of the man, which says he's 2 meters. That's point D. All right, the fact that the shadows had to coincide is essentially allowing this line of sight to the sun and the end of our shadows to create the same angle. Okay, and we've also got the right angles. We know he's 2 meters tall, and he is having a shadow of 1.6 meters. Okay, could I say X compares to 2 as 4.4 compares to 1.6? So I end up with 8.8 is equal to 1.6x. X ends up being 5.5. Okay, and everything was in meters, so it's meters. Okay, I'm assuming since you had 55 that you might have just missed a decimal place sometime when we typed it in your calculator, or maybe you just didn't write it. So there's no unit issues there to really see why we've got 55 over 5.5. So 5.5 is the right answer. And we'll get to the next question, 17. There is a unit situation here that needs to be kind of discussed and talked about. When we look at these two essentially triangles that are being created here, and this happens every time you go to a movie. It's happening in front of you right now with the projector. There is a film that is over or kind of in front of a lamp, a short distance from a lamp. A lamp then a light passes through that film, and then there's a certain distance that light keeps traveling until it meets a screen. Well, that distance that is between the film and the screen, the further that is, the larger the object becomes, right? You guys have all done that, correct? You take a projector, if I'm really close to the wall, the screen is going to be very small. I take that projector and I start working backwards. The viewing screen gets bigger and bigger, right? Obviously, the closer I am to the wall, the sharper the image. The further away, there's more space that those photons have to travel through, so that the image gets a little bit blurry. Okay, but hopefully we all understand it. We experience this all the time in classrooms and movie theaters and that kind of stuff. Okay,
it's really clean in movie theaters, but it's far away.
Right, so they've got some good lamps, good projectors and stuff like that. Yeah, so, and the lights are off.
Oh yeah.
So there's no light pollution. But what we want to assume here or understand, because we need similar triangles, right? And we need angles that are congruent, correct? So if I look at the situation here, we should have. I'm just going to draw the two triangles. We've got a situation where we've got L and F here, so that's the lamp and that's the film. And then we've got another triangle where we've actually got the lamp and then the screen. Right now, would you all agree that that angle right there is that one?
Yes.
The lamp angle is in both those triangles. So that's one angle congruent to one angle. But now we need a second angle. We need, and it doesn't matter which ones we look at here, Hold on a second, my tablet froze. There we go. Doesn't matter which one we look at, but I need maybe that angle congruent to that angle. Does that make sense? Well, those two angles would be that one there and that one there. Is that all right? In order for those two angles to be congruent, what is the assumption that I need to know about the film, the orientation of the film, and the orientation of the screen? They have to be what to one another? No. How do they have to be placed?
In front, like on top, like the two have to be parallel.
They have to be parallel. Okay. If my film, let's say that my film is not parallel to my screen. Let's say that my film is kind of like that. Okay. When the light passes through that, that's going to create distortion. All right, and you're going to see like maybe the upper half of your image on the screen be blurry and stretched vertically. Does that kind of make sense? Okay, and maybe the lower half will be compressed. Therefore, the two images would not be similar images of one another. Okay, because they're just out of scale. So that's what we want to do is we want to make sure that they are parallel to one another. You guys have seen this before. I could take. Let me see if I can do this with my projector.
Are you trying to make it like blurry or something?
No. Maybe.
I don't know what happened.
You guys kind of see what that's doing right now?
Yeah.
And use that key. It's called a
Whoa.
keystone. So what that's doing
It's like tilting
is it's essentially taking the image that is in front of the projector. It's in the. If I come back over here and look in front of the projector, I can see that image. Kind of, it's really bright, but I can kind of see that image in front of the light. Does that make sense? And what this is doing is taking that image and starting to spin it and rotate it. And now it's not parallel to the wall, right? So now you kind of see this trapezoidal display. Well, if they're parallel, so this I would use this if my wall obviously was not a vertical wall, or if I couldn't mount my projector so that it was
like up there, like
parallel to the wall.
Wait, so you could technically like have it like the whole thing on the wall slanted in.
Yeah.
That'd be so
Yeah.
cool.
So this will adjust that. So now at that stage there, maybe we are
See how far it goes.
parallel. Okay. So that's kind of what's going on here, and we have to make that assumption because if we don't, then we don't have similar triangles, and then our images are not going to be to scale. Okay. So when we look at this and start to fill in information, we do know that these two triangles are similar. This is 6 centimeters, okay, distance from the light to the film. This is 24, right over here, 24 meters. They tell us that the height of the giraffe on the wall or on the screen is 2.2 meters. And then they ask us for how tall is the giraffe on the film, okay? Once you get that set up, I don't think anybody's going to have issues with saying, well, X should compare to what? 2.2. Okay, and then 6 should compare to what? 24. Okay, now I put my units in there just to make sure that we pay attention, because if I cross multiply right now, I'm going to get an answer. And let's just real quick kind of show you this. If I cross multiply, you get 2.2 times 6. Sorry. Okay, 2.2 times 6, and then I'll divide that by 24, and I get 0.55. Okay. Now we're going to see if that Now, because I didn't change my units and all that kind of stuff, I might have an issue here. Okay, 2.2 times 6 and divide that by 24. That's actually, in this situation, it's going to give me the right answer, but you may come across the wrong answer or mistakenly because you've seen how it works here. Okay, the only reason this works here and gives me the right answer is because when I cross multiply, I get 24 x meters. Does that make sense? If I put my units in there, is equal to 2.2 times 6 meters times centimeters. Does that make sense to everybody? Put my units in there?
Yes.
Now, if I divide both sides by 24 meters, come over here and divide by 24 meters, what happens to these meters here?
Cancel out.
They cancel out. And now I have my answer, just the only units left over is centimeters, right? So in this case, I do get a distance, but now it develops the centimeter unit for me. Does that make sense? Okay. There are going to be times when you have to make sure that you're paying attention and realize that there's algebra, there's math being done with your units, so that you know whether you're in the correct unit for an answer. Okay. Now they didn't tell me how to leave my answer, so this would be fine. But if I just got 0.55 and I'm on a multiple choice test or I'm on the end of course exam test, and sometimes they will ask you there'll be a box for the number and there'll be a box for your unit. If I got 0.55 but then I put M in there, I'm wrong, right? Okay. So we have to be able to know the units, because that's as important as the number that's attached to it. So this is kind of what I would do, guys. I would take this 2.2 meters and change it right now into what? Centimeters. Okay? So now I have 220 centimeters, correct?
Yes.
Equal then to 6 centimeters. And I'll take this 24 and change it to 2,400 centimeters. Okay? And the way I do that, we should know that there's 100 centimeters in every meter, right? Okay? If you didn't know that, you guys in science know died by, I got it backwards. King Henry died by chocolate milk. So kilo, hecta, deca. Oh yeah, but this is base, right? Deci, centi, and milli, right? So if I'm at, my base is always going to be either meters, grams, or liters, right? Right now we're talking about distance, so we're at meters. So I take my, it was 2.2. I put it there. And now if I want to go from base to centi, I go one spot, two spots, right? So that's where the decimal goes. Follows the same pathway, one spot, two spots, you put a 0 in. So 220. Do the same thing for 24, and I get 200 or 2,400. Is that all right? Now the reason I would do that is because now all my units are in centimeters, and when I'm done, there's absolutely no question that my answer should be in centimeters. Does that make sense?
Yes.
Okay. Like I said, you could, and it's just because of the configuration of the values that they gave us in this question, you can sometimes neglect units and just by coincidence get the right answer. Get the right units to kind of cancel out and show up. Okay? That is by far not always the truth. Okay? So make sure that when you're doing these, if you've got varying units, you change them over. And I think you guys might have seen that on one of your questions on the quiz last week when one dimension was given in feet and the other was in inches. And just the algebra we did, if you didn't adjust for that, you didn't get the right answer. Okay? So I think that's important for us to understand. Now I know my answer is 0.55 centimeters. Okay? Could I have done this? Could I have said, well, I'm not going to take the centimeters, and I'm going to convert that into meters. How many meters is 6 centimeters? Careful. I'm right here. I'm at 6.0 right there at C, right? That's my unit centimeters. I need to go 1, 2 spots to the left, right? So Megan, what did you say? 0.06. Now it's in meters. Come on. Now it's in meters. And now when I cross multiply, I'm going to have 0.06 times 2.2 equals that number. I'll divide it by 24 now. And I get that number. 0.0055 meters. Does that make sense? So either one of those, because it doesn't tell you how to write your answer, centimeters or meters. Either one of those is fine. Okay? But if I got 0.55 meters, I'm wrong. Does that make sense, everybody? I got to have the right unit to fix. And does that make sense? Are those the same? Well, if I'm at 0.0055 meters, if I'm right here, and I want to go to centimeters, that means moving my decimal 2 spots to the right, correct? So if I move 2 decimal places to the right on that black number right there, I get the red one. Okay, that's kind of the thing that is somewhat problematic in a lot of the math that we do is that to address it and to do these sort of problems, you have to have a lot of kind of foundational conversion skills that maybe you practiced in the 7th and 8th grade math courses, but hopefully you got really good at in your science classes. Okay. The last one is not too hard. The last one is just like the one we saw on the PowerPoint a couple days ago. Okay, with this girl in the mirror. But there is one thing that you got to pay attention to get the right answer. Okay. It says that the girl is 172 centimeters tall, right? 172 centimeters tall. Says she's 120 centimeters from the mirror. Is that okay with everybody? And then this M to A prime was 4.5 meters, right? Can I do that? Can I just write 450 centimeters?
Yeah.
All right, they asked for X. Okay, so I put everything in centimeters, so my answer don't get centimeters, right? Could I have put 1.72 meters, 1.2 meters, and that's 4.5 meters, and my answer is going to be in meters? Okay, so being able to jockey back and forth between units is going to be a very important skill, especially as we move on throughout the course. Okay, it's going to be a huge component of the course. If I use those components, okay, let's say that what is 172? If these two triangles are similar, what is 172 going to relate to? It's going to go to X. Okay, what is 120 going to relate to? 450. Okay, now if we did that, if we did the cross multiplication here, we are wrong for the question that they're asking. Okay, because when you look into that mirror and the light that we're using to bounce off the mirror, so this dotted line is light, right? Light rays bouncing off that mirror, or light waves, and then coming back up this line into your what? What allows you to perceive light and to see images?
Your eyes.
Your eyes. Okay? So that dotted line on that left-hand triangle is going to her eyes. It's not going to the top of her head. Top of her head is 172. To her eyes would be what? 160. So we need to put 160 in there, okay? Because that is the height of that triangle on the left-hand side to get to our eyes. The question we did in the PowerPoint kind of neglected that, okay? I didn't talk about that. And sometimes the question will, sometimes the question won't. So you always got to kind of pay attention. Are they asking me, are they telling me something extra here about where her eyes are located or something like that to allow you to adjust? And when you cross multiply here, you get 600 as X. Okay, so X is going to be, if you evaluate this, you'd get 160 times 450 divided by 120. You can cancel zeros there if you want to, but multiply that, you get 600 centimeters, right? Okay, if I'm measuring a flagpole, okay, Should I use dimensions like centimeters to do that?
No.
No. Is it wrong?
No.
No.
It's just not smart. Right.
Yeah, but if I want to do something extra with that 600, maybe I want to say, well, how much metal do I need to make 12 flagpoles?
Like,
I don't want to take 12 times 600, right?
Yeah.
Okay. I'd rather take 12 times
like 6,
right?
I don't know.
So instead of centimeters, it's 600 centimeters. Let's change it to 6 meters. Okay. And that idea, and it doesn't tell you here. So if you said 600 centimeters, you're right. If you said 6 meters, you're right. If you said, okay, so if I'm King Henry died by drinking chocolate milk, okay, we just figured out that we were at 6 meters, right? If you said 0.6 decameters, you're right. Okay? If you said 0.06, I don't know, hectometers or hectometers, okay? If you said that, you're right. If you said 0.06 kilometers, you're right. Does that make sense to everybody? Okay? Because it doesn't tell you specifically what unit they want. But understand, to measure the height of a flagpole, doesn't really make sense to use kilometers to do that, right? Because that number up front is an ugly number. It's a much nicer number if I can use it as a small whole number. All right? Go ahead.
Is centimeter or kilometer? I don't know what kilometers.
Kilometers are,
Isn't that in like?
they're relatable to miles. Kilometers is 1,000 meters. Okay.
Doesn't
So it's a little bit more than half a mile.
we use miles per hour, but other people use kilometers?
We're one of the few that use miles per hour.
Aren't we the only country?
I think there's 3.
Really?
We use it. I think Brussels uses it.
Brussels?
Not sure what the other one is. Okay.
Brussels.
You guys know why we still use it?
No. Because it's too hard to change it.
Why is it too hard to change it?
Because we're gonna have to reteach everything, change all the signs.
The financial burden of changing
It's like
everything from miles to kilometers. Just think about all the signs, all the stops, not signs.
What about a car?
Speed limit signs that you see that say 60 miles per hour, right? Think about the cost of changing all those to 60 kilometers per hour. Or whatever, it wouldn't be 60, but whatever that rate would be. So it's just not feasible for us to change. Is that right, everybody? When you're measuring things that are small, use a unit that is appropriate. Use a unit that measures small things. If you're measuring things that are long, like the distance between here and Ontario, okay, you're going to use units that are large. Okay? We are going to spend time, because I think it's extremely important because of the world that you guys are in right now, to be able to understand the relationship between miles and kilometers, yards and meters. Okay, because it's the more and more that we start becoming more and more international as a world economy, things are presented that way, right? And it's important for you guys to understand those and be able to compare and relate those things. So we'll spend a lot of time in this class dealing with converting back and forth between both systems. Can we do this stuff? Do we feel comfortable with it?